Newton's corpuscular theory. Today we're going to learn about Newton's corpuscular theory. Sir Isaac Newton's corpuscular theory was one of the earliest scientific attempts at understanding the nature of light. Even though it was originally set forward by Pierre Gassendi, it was Newton who had later developed and proposed the corpuscular theory of light way back in the 17th century. However, after 100 years of existence, it later gave way to a more popular Huygens wavefront theory that could explain some of the limitations of Newton's corpuscular theory. Newton's corpuscular theory of light states the following. Light consists of corpuscles, which are a stream of discrete, tiny, light, and perfectly elastic particles. Every luminous source, like the sun, a lamp, or a candle, emits these corpuscles. These corpuscles travel in straight lines in all possible directions. The rate at which these corpuscles travel may differ depending on the medium in which they disperse. The vision of human beings is a consequence of these corpuscles falling on the retina of the eyes. Various colors of light are due to the difference in sizes of these corpuscles. These corpuscles could perfectly explain the concepts of reflection and refraction of light. The reflection of light, which consisted of corpuscles, is just like the reflection of a perfectly elastic ball. Consider the case of a perfectly elastic ball that hits the wall, which is a rigid plane. When this ball hits the wall normally, it bounces back and travels along the same path that it takes during the throw. However, when this ball is thrown at an angle to the wall, it bounces back and away from the wall at an equal angle with respect to the normal. However, it takes the opposite direction. The angle of incidence, I, of the ball is equal to the angle of reflection, r. Reflection of corpuscles of light follows the same rules that reflection of this perfectly elastic ball exhibits. In other words, each of the corpuscles behaves just like an elastic ball. This means that when corpuscles hit the surface normally, they travel along the same way back, and when they hit the surface at an angle, they are repelled near the surface and reflected back such that the angle of incidence, I, is equal to the angle of reflection, r. According to Newton, the refraction of light was due to the supposed change in the speed at which they travel, thereby causing a resultant change in the direction whenever these corpuscles enter from, say, a denser medium to a rarer medium. Although Newton's corpuscular theory of light could successfully explain the reflection of light, his assumption of higher velocity of light in denser medium as compared to the rarer medium has been disproved. He was also unable to validate his supposition that various colors of light are due to the difference in sizes of these corpuscles. For these reasons, the hypothesis was rendered baseless. The biggest limitation of Newton's corpuscular theory of light was that it could not illuminate the phenomena of interference, diffraction, and polarization of light. This is why the theory was later abandoned in favor of Huygens' wave theory of light, which proved that the light travels in the form of waves.